Let's take a look first at the storage model section of the XML. So I'll expand that there. And there you can see all of the objects. Like the conceptual model, there's a schema element that is the container for all of these objects. Notice though that schema uses a namespace of awltmodel.store, unlike the conceptual model. And this is to distinguish it from the conceptual model namespace. And that was just awltmodel. And then, because the Entity Data Model Wizard reverse engineered this model from a SQL Server database, the provider attribute is system.data.SQL client. And the provider manifest token is 2012, indicating that it uses SQL Server 2012. Now this is a little bit misleading. I actually created this from SQL Server 2014. So this is yet another way that Entity Framework hasn't quite been brought up to the latest version of SQL Server. But it works. And then it goes on to define a few namespaces that it uses within the XML data. Now, one note about this. If you were to change versions of SQL Server that you use with this model, such as to downgrade to SQL Server 2008, make sure that you change the value of this provider manifest token. Entity Framework uses this value to implement database version-specific features. So if it's out of sync, you'll have problems. This can be a problem if you move the application between development, test, and production servers that have different versions of SQL Server. You have to change this value in the XML since it isn't exposed in the designer or the properties window. Okay, so like the conceptual model, the storage model has this entity container object that contains all the tables. But here they're called entities. Even though these are tables, they're called entities for consistency with the conceptual model. And as you can see, it has the name here of alt model store container. And then it consists of child entity set and association set elements. The storage model uses an entity set element for each included table in the database, with the table name here and an entity type attribute there that provides a fully qualified name, but still the table name in the database. It also identifies each of the entity set types as type table and includes a schema name from the database. So it's important to understand that all of the objects that I included from the AdventureWorks LT 2012 database are in the Sales LT schema. So that's the only one that's going to appear here. All right, and remember that I included 3 views when I reverse engineered the database. So the storage model also uses an entity set element in order to describe the view, but it has a different structure. So if I expand this for vGetAllCategories, or the GetAllCategories view, first of all, notice that the store type is views and the schema is still Sales LT. But the big difference is that the view's entity set element has this defining query element that contains the SQL statement that defines the view within the database. Okay. The entity container also includes these association set elements, and these describe the table relationships defined in the database, the referential integrity. And so I can expand that, and here's the relationship between the customer address and customer table. All right, so that's the entity container. And then, once again, like the conceptual model, there are also entity type and association type elements as well. So here's the entity type for the customer table. It defines a key. In this case, this is the primary key of the table. And then it has the schema, or some of the schema, of the customer table. So here's the property, has customer ID, it's type int, store generated pattern is identity, and nullable is false. All right, then the last entity type here is association. Expand that. And this should look pretty familiar from the conceptual model as well. Okay, so that's the structure of the storage model. To emphasize a point, you want to notice that the storage model uses entity model terms for objects for consistency with the conceptual model. So the storage model has entity types and properties instead of tables and fields or even columns. If you work intensively with relational databases, this can be a little bit unnerving. But when working with Entity Framework, you'll need to think in entity terms anyway. So just deal with it. All right, so as you can see, a lot of similarity between the information contained in the conceptual and storage models, including the numbers and types of entities and properties, as well as associations. But this close similarity is because the model was generated from a database, and I've not yet customized it in any way whatsoever. If you were to make deep customizations to the conceptual model using the designer, to make its resulting entity data objects easier to use and more in line with the application domain, then there would be radical differences between the conceptual and the storage model. Okay, so let's talk about the mapping model now. I'm going to collapse the storage model here and come down here to mappings. So this model is between the conceptual and storage models in order to map entities and properties from one to the other. And it also allows various model configurations. All right, so the top element is EDMX mappings. And that has a single mapping element as its child. So this is a departure from the conceptual and storage models where the schema was the single child object or child element. And this defines the XML for the schema right there, as well as C-S for space. This just means that the model is mapping from the conceptual model to the storage model, so C-S. All right, then this entity container mapping element is the container for the actual entity mappings. This element uses the storage entity container right there and the CDM entity container, that attribute right there, to link the storage model named AWLT model store container and the conceptual model named AWLT entities. Remember that these were the values of the namespace attribute of the entity container elements in the storage and conceptual models, respectively. All right, then we have these entity set mapping elements. Each of these defines the mappings for each entity in the model. So I'll expand the one for customers. And an important thing to notice here is the mapping is based on the entity set, not on individual entities. This means that the entity set mapping element is for the customer's entity set. So you can see that right there, not the individual customer object. This is to accommodate inheritance, in which the entity set mapping covers the base and the inherited objects together. All right, so the entity type mapping defines which entity type is being mapped by the element, and here it's the customer element. So there's the customer. The mapping fragment element supports entity splitting. That's where one entity can consist of properties from multiple tables in the database. There will be one mapping framework for each table, but because the AWLT model is derived directly from the database, each entity type mapping has only a single mapping fragment, with properties coming from only one table in the database. And so here, the customer's entity set mapping is mapped to the customer table in the database. Now, you can certainly change that. You can expand on it. Entity Framework supports a lot of scenarios with data for a single entity coming from multiple tables, or vice versa. All right, then the scalar property elements here map the entity property name in the name attribute to the database table column name in the column name attribute. Again, because I haven't customized this model, the names in the entity and the table are identical, but you can customize those as much as you want, as long as you use valid names. The mapping section in the model keeps straight which entity properties map to the table fields, no matter how you change the property names. It's really pretty cool. All right, and then if you were to go back into the designer, you can see how the mapping details in the MSL code within the EDMX file, they relate to the mapping details in the mapping details window within the designer. Okay, then scrolling down here, we don't have it here, but if you don't use foreign keys in your model, you'll probably also see association set elements in the mapping section in order to define how one entity is related to another. Okay, so that wraps up the overview of the XML that defines the entity data model and entity framework. It might be a bit overwhelming, but that's really just because of the sheer volume of the XML in the file, even for relatively simple models like that for the AdventureWorks LT database. But the XML itself is relatively straightforward and generally relates well to what you can see graphically in the entity data model designer. You'll need to be familiar with the underlying XML to have a good understanding of entity framework so that you can use it effectively. So it's well worth taking the time to explore it, particularly as you make customizations to the model. As you've seen, the EDMX file in the project contains the XML for all three of the entity data models, as well as some support for the graphical designer for the conceptual model. But Entity Framework requires 3 XML files at runtime, so part of the build process for the project is to split out those 3 files from the EDMX file. It saves the conceptual model to a CSDL file, which stands for the Conceptual Schema Definition Language. It saves the storage model to a file with the SSDL extension for Store Schema Definition Language, and it saves the mapping model to an MSL file for Mapping Specification Language. By default, the build process embeds the 3 XML files into the project assembly as resources, which ensures that they're always available when needed for data access. But you can change this behavior so that Visual Studio places the 3 files in the output directory where you build the project. Here I am back in the AWLT project, and I have the entity data model opened up in the designer. If I go over to the Properties window with the model selected, you can see that I have this metadata artifact processing property right there. Make the window a little bit bigger. And I currently have the value set to embed in output assembly, which is the default. So I'm not going to change that, but I'm going to come over here and rebuild the solution. And then I'll go over to Solution Explorer. Notice that I have the configuration management set to debug. So here I am within the debug folder, which has all of the output files for that project as a result of building it. So as you can see, I have a total of 8 items currently. And also notice that the DLL, or actually the EXT here, EXE, is 102K in size. So that's the output assembly. It's a console application, so it's implemented as a .exe file. Now I'm going to come over here back to the project, and I'm going to change that. I'm going to double click on it to copy those model files to the output directory. So I'll once again, well actually I'll save it first, just to be absolute sure. And then I'll rebuild the solution one more time. Succeeded. And notice that I now have 11 items because I have these 3 model files right there. And also notice that the awlt.exe file has gone down dramatically in size. Now, it's dramatic only because this is a console application. I haven't actually added any code to the console part of the application, so there really isn't much else going on in here other than the entity data model. So it took out a majority of what was in the DLL because they are in these 3 files. And if you had opened those up within a text editor, you'd see that that is the XML for the 3 different models: the conceptual model, the storage model, and the mapping model.